Okay, this is the review for our last test before the final on Unit 6, Part 2. The first question says, a student is tracking the height in meters of a firecracker over time in seconds. And the question is, what conclusion does the data support? And we need to circle all that apply. Make sure you read the question. This says all. So our x-axis is time. Our y-axis is height, and you recognize the shape. Looks like a parabola, looks like a quadratic equation. We did those for quite a while. So the choices here are, the firecracker will not go above 350 meters. Well, if we find the maximum up here and go over to the y-axis, we see that's 350. So yeah, that's true. It's not going to go above 350 meters. We could circle that one. After 6 seconds, the firecracker will hit a height of 400 meters. Well, we just said it won't go above 350, so that's impossible. The firecracker can reach a maximum height after only 4 seconds. Well, if we find 4 seconds here and we go up, well, that's not the maximum, so C is not true either. The last choice is the firecracker reaches its maximum height at about 7 seconds. So if we go over here to 7, between 6 and 8 right here, and go up, well, yeah, that's about where the maximum is. So we have two true statements here. Okay, question 2 is about a two-way table. We have a two-way table here about liking or not liking snowmobiles, or liking or not liking skateboards. And again, we need to read the question carefully, because it says which statement, singular, just one statement, about the following two-way table is not true. So starting with A, more people like snowmobiles than don't like snowmobiles. Well, if we go down to the total, we find, if we go over to the total, we find that 105 people like snowmobiles and 55 people total don't like snowmobiles. So this is true. More people do like snowmobiles than don't like them. But if we look at the B choice, overall, more people do not like skateboards than like skateboards. So here are our totals for that. The people who don't like skateboards, the people who like skateboards. Well, 125 like skateboards. So this is not true. We can't say that more people do not like skateboards than like skateboards. So our answer would be B. And the other two choices go into relative frequencies, but if we read our question carefully, we know that this is the one that's not true, and we don't have to go any farther. So reading is a very good idea on these tests. Read the instructions. And number 3 says, a reporter surveyed 150 randomly selected people of all ages about their favorite sport to watch on television. The results are shown in the table below. Here's our table. Which of the following is a valid conclusion or a true statement about the data? And it says select all that apply, and that means that more than likely more than one of these is going to be true. So we're going to have to look at each one. So let's start with the first one. Most people prefer football. Well, looking at the chart, the totals are down here, the table. The people who prefer football, 52. Those who prefer basketball, the total is 38. For baseball, it's 60. Well, that's the biggest number, so this is not true. Of the males surveyed, so we're only looking at the males here, football was the favorite. Let's see, we have 40, 22, and 15. Yes, 40 was the biggest number, so B is a true statement. We're going to circle that one. Of those that chose baseball, most were female. The ones who chose baseball are right here. We're only looking at this column. Of those that chose baseball, most were female. Males were 15, 45 females. So yes, most were female in that category. So we can circle C as correct as well. Now, D says about 58% of those that liked basketball are female. So we're going to have to do a little calculation here, relative frequency. Now the key, again, when it says of those who liked basketball, that lets us know that we're talking about the number that's going to be in the bottom, on the bottom of the fraction, or in the denominator of the fraction, of those particular people. So those that liked basketball, the total is 38. So that's going to be our denominator. And it says about 58% of those are female. So let's see, the number of females who liked basketball was 16. So if we divide 16 divided by 38, we get 0.42. And if we move the decimal point over twice, that's 42%, or multiply by 100. That's the actual way to think about it. So D is not true. It's 42%, not 58. All right, so let's look at E. About 40% of people surveyed prefer to watch baseball on TV. About 40%. The of here is of people surveyed. So we want the total number surveyed. Well, we know that's 150. So that's the number that's going to go in our denominator. How many out of these 150 prefer to watch baseball on TV? Well, let's look at our totals. The total number who preferred to watch baseball is 60. So then we again say 60 divided by 150 is 0.4. If we move that decimal point to the right twice or multiply by 100, that gives us 40%. So E also is a true statement. On question number 4, it says the graph below shows a line of best fit. We have a scatter plot here, all those points everywhere, and we've drawn a line of best fit that best represents the data here. It says it's the distance bicyclists have remaining in relation to the amount of time they have been riding. So in other words, this is the time they've been riding, and this is the distance they have left to travel. So that's getting smaller and smaller because they're getting closer and closer to their destination. So the question is, what is the equation of the line of best fit? So you got to reach back in your memory banks to those linear equations. The general form was y equals mx plus b, right? Where m was the slope and b was the y-intercept. You guys were really good at these. So just looking at our choices here, we can see that the y-intercept for each one is 170, which is correct. 170 is right there where it crosses the y-axis, so that's not going to help us choose. We know that the slope here is negative because it's going down. So that's helpful because that lets us know it can't be B and it can't be D. They have positive slopes. So now we have to figure out what the slope is. And from a graph, remember we choose 2 points and then we do rise over run. So let's choose a point, maybe this point here, and maybe this point here. So rise over run. In this case, it's going to be a fall. We're falling, so it's going to be a negative rise. So we go from 160 to 120 there. The distance between 160 and 120 is 40. And then the run here goes from 0.5 to 2. So in other words, 1.5. 1.5. So let's see, 40 divided by 1.5 gives us 26.6. So about 25. So we can say that A would be the correct choice here. In question number 5, it says in the data above, what percentage of females are right-handed? So we're not looking for the number, we're looking for the percentage. And it says of females. So that's our clue as to what number is going to go on the bottom of the fraction or as the denominator of the fraction. So females, how many females total do we have? Well, we have to look across here because there's the female category. We go across, we see that there are 53 total, and that lets us know 53 has to go on the bottom. It's of females. What percentage of them are right-handed? So looks like 46 of the females are right-handed. So that's the number that goes here. And then we figure out that percentage, 46 divided by 53 gives us 86, or about 87.87, or 87%. So our C choice is the correct one. Number 6, a group of men and women were polled or asked about whether they go running daily. The joint and marginal relative frequencies, those are vocabulary words that we learned in our Go Formative lessons, corresponding to the results are shown in the two-way table, and they ask us what the value of y is. So they give us a lot of the relative frequencies, but not all of them. And this is, don't be confused by this, they've written them as decimals, and then we have a 1 here. You could also write those as percentages. This would be 100% here, and then this would be 70%, 30%. It's the same thing, just a different way to write it. But what's important to know is everything has to add up in our totals column. So if they want to know what y is here, well, we know that this column, the women who do go running daily, plus this number have to add up to this number because this is our total. This plus this equals this. So if we write that out, 0.3 plus y equals 0.4. Well, what do we have to add to 0.3 to get 0.4? And the answer is 0.1. So our D choice would be the correct one. Okay, number 7. The following scatter plot, see all those points, that makes up a scatter plot, shows Pam's training as she prepares to run a 6-mile race at the end of the month. Which of the following would be a reasonable approximation? That just means a good answer, the best answer. For the length of time it would take for her to run 6 miles. So first thing we do, every time we look at a graph, we figure out what the x-axis represents and what the y-axis represents. The x-axis is distance, and the y-axis here is time. So if we're looking for 6 miles, we got to look on the distance axis here, the x-axis, and we see that 6 is right here. Well, if we go up, there's no point up here. So that's when we have to rely on our line of best fit. So I'm going to try to sketch it. You guys know Miss Holt's not an artist. But if I drew the line to capture most of the points and have about the same number above it as I have below it, then if I look at the 6-mile marker, and I go up here, and then I go across to see that value, it's about 60 minutes or an hour. So choice D would be the correct one. Okay, number 8. Which data set, each of these is a data set, has the weakest correlation? So a strong correlation is when the dots look like almost a straight line. That's a very, very strong correlation. And the farther the dots get apart from each other, the weaker the correlation. Well, this one's weak, this one's pretty weak, but look at this one. It's all over the place, a very weak correlation. So our choice here would be C. All right, question number 9. Data was collected on the hair color and the height of a random group of people. Identify the correlation you would expect to see between hair color and height. Correlation just means, do they affect each other? Is there a strong correlation? Is there a correlation at all between these two things? Well, does your height affect your hair color at all? No. So when we look at these choices here, constant, positive, negative, we have to choose no correlation. There's no association, no correlation between hair color and height. Okay, this problem's just a little bit more involved, but it's two-way tables. You guys were really good at these. It says use the following information to answer the questions below. We have part A is completing the table, and then we have part B, C, and D. Incidentally, some of you forgot to complete the table on the performance final. Make sure you're reading the instructions. If it tells you to do something, you got to do it to get full credit. So if we're going to complete this table, we have girls and boys, and we're deciding, or we've surveyed them to find out if they like jalapenos, mayonnaise, or mustard. So we have a total here of all the rows and totals here of the columns. All right, so all we have to do is add and subtract here. We're gonna, if we want to know how many who like mustard here, well, we know our total is 57, so we have to say 57 minus 42. 57 minus 42 is 15, so we can put 15 right there. All right, and then in order to figure out what goes in this total column here, we can add this, this, and this together to find out what goes here. So we have 35 plus 33 plus 15 equals 83. So we know 83 goes here. Well, now we can add these two totals together to get the total number of people who were surveyed, 83 plus 112. So let's do that. 83 plus 112 is 195. So we can put 195 here. Okay. Now we know that these three columns here, these three totals here rather, should add up to 195. So we need to take 195 and subtract 57 and 63. All right, so 195 minus 57 minus 63 gives us 75. So that lets us know that here in this spot should be a 75. Well, now we have another clue here, because 35 plus whatever goes here has to total 75. So we can say 75 minus 35 to figure out what goes here. 75 minus 35 is 40. And then we only have one more box to fill. So we can say that we have a total here of 63. And 33 girls liked mayonnaise, so we have to say 63 minus 33 to figure out how many boys liked mayonnaise. 63 minus 33 is 30. Okay? That's how you complete the table. Now we have to answer the questions down here. It says, how many girls were surveyed? Well, to find that out, we have to go all the way over here to the total of the row, 83. Part C asks, how many boys and girls, both, liked jalapenos on their burgers? So we need the total for jalapenos. So find the jalapenos column, go down to the bottom. There's the total, 75. Part D, what is the percentage of girls? We're looking for a percentage here. That's the key word, of girls. So that lets us know that the number of girls is going to be on the bottom of our fraction. I'm going to put it down here. Number of girls is 83. We already said that. That's going to be in the denominator of our fraction. What percentage of girls that prefer mustard and jalapenos, so we need to combine those two numbers, mustard and jalapenos, on their burgers compared to the total number of girls in the survey? So the ones who preferred mustard, 15. The ones who preferred jalapenos was 35. We have to add those two together. 35 plus 15. 35 plus 15 is 50. And then we say 50 divided by the total number of girls, which was 83. And we get 60.60, or 60%. Okay, and the last question. Do boys or girls, which one, tend to prefer mustard more? It says explain your answer using information from the table, okay? So we have our mustard category here, And looking at the number here, we have 42 boys that preferred mustard, and we have 15 girls that preferred mustard. But now look, there are 112 boys that were surveyed and only 83 girls. So we might not be able to just look at the numbers to get our information. This is when it's a good idea to use relative frequencies to figure it out. So I'm going to figure out the relative frequencies of both of those. First of all, 42 divided by 112. 42 divided by 112. That gives me 37.5, or we'll say 38%. So the relative frequency here is 38%. And now if we do it for the girls, 15 out of 83, we get 18% for our relative frequency. So we can say that with more certainty that boys prefer mustard. So we can say the answer is boys.